We will start simulating a situation where we have a large amount of Kanban, 5 for each station. That is a way above what we need according to theoretical calculation, but we will see what would happen if we would use this configuration. So we are going to our model, and I'm going to type 5 for every parameter corresponding to the number of Kanban of every station, and I will leave the warm-up time and the runtime as we had it before. So I'm going to run the model in a fast-forward way, and we'll get results. So we expect to have a very large amount of stock because we have a huge number of Kanban, and that means having useless products because there won't be customers withdrawing them. Actually, we see we have 4.5. I didn't comment on that in the previous videos, but these numbers here correspond to the average number of articles we have. So we have almost 5 here, almost 5. Very few here, which is consistent with the fact that as soon as we have a product here, this station will withdraw it. So they don't stay here for too long. And we have almost 1 on average here. And what we have here is the level of occupation of the stations. So we have this station working full-time, 100% of the time, and the rest are idle quite some time. So they are station 1 and 4 are occupied 50% of the time, and station 2 a little bit more. It's 62, almost 63% occupation. And we have a month average. I want to pay attention to these values here of 36,000, stock cost of 18,000, and the benefit of 18,000. And we're losing some customers. Okay, we have a 21,000, but these are not that many because we are having a service level of 63, which is most or around the most value we can try to attain. This is our average WIP and the throughput rate, which is the time it takes for an entity to go along the system and actually leave it. Okay, so we see then the results. We have a summary here. We have a benefit of 18.5, an income of 36.6. A cost of 18.2, this value for the WIP, the average WIP, the throughput, and the service level. Okay, so we can see that workstation 1 and 2 have very high stock levels that we saw here. This means we have 5 most of the time, and or 4 or 5, which is a lot because we are not using that. The same thing happens in station 2. Okay, we also have workstation works. Has works all the time, and we might think about reducing the number of Kanban in workstations 1 and 2 because we don't need that many number of Kanban. So we might be able to provide a service level which is as good as the one we have right now, but we have less Kanban in stations 1 and 2, and due to that we would have less stock cost. So we would be making the same benefit, roughly the same, and we have a smaller cost, which is good for the performance of the system.